Section 9.1, which again starts on page 462. We're going to look at the 6 different trig functions. In your career so far, you've only dealt with 3. You've dealt with sine, cosine, and tangent. Your geometry teachers, did they tell you anything about SOHCAHTOA before? Yep. Okay. That's a little bit about that as well as something else. So, the sine ratio, again, was opposite over hypotenuse. I'm going to abbreviate just so that you guys know. But this symbol that I have after the word sine is theta. Okay, it looks like a circle with a little loop through it. That's theta. That just stands for angle. Okay, so if, in case you're wondering, that's what that means. Then we have cosine, which if you think about SOHCAHTOA, it was CAH. What did the A stand for? Adjacent. And what did the H stand for? Good. And then the tangent was TOA. What's the O stand for? Opposite. And adjacent. Okay? Now, if I'm referring to, and in this particular context today, all we're going to refer to is the right triangle. Theta is going to be one of your angles marked like that. So if that's theta, this side is known as the hypotenuse. Why is that the hypotenuse, you guys? Do you remember from last year? It's opposite of the right angle. What else did we say? Okay, longest side, some other things like that. What's this one over here? Opposite. How did you know it was opposite, Bryce? It's farthest away from the angle, right? Theta. And the adjacent then has to be this one. Adjacent means right next to. Like, I am adjacent right now to Abby, because we're right next to each other. Okay? That's what that means. Is everybody okay with that, or remember what that is? All right. Now, here comes your 3 new ones. Sine, cosine, and tangent are ones that you guys have had before. The next one that you're going to have is cosecant. Cosecant is abbreviated by CSC. Okay? Cosecant is the reciprocal of sine. So if the sine curve was opposite over hypotenuse, hypotenuse over opposite. The next one is called the secant. The secant is the reciprocal of the cosine. So what would this one be then? Hypotenuse over adjacent. Good. And the last one is called cotangent, or abbreviated by cot. What do you think this one's going to be? Adjacent over opposite. And this is all we're going to look at today. I'm going to give you a scenario, and I'm going to ask you to write the 6 different trig ratios. That's what's going to happen. Okay? One of the things that you might have to do is go back to your geometry roots and find one of the missing sides of a right triangle. How do you find the missing side of a right triangle? A squared plus B squared equals C squared is correct. What's that called? The Pythagorean Theorem. Good. So, just so that you guys know, you might have to use that in order to find the missing side. But all we're going to do is write these 6 different fractions. Okay? Or use the fraction and work backwards to find the other ones. So, here's what's going to happen. They're going to give you a triangle like this. Okay? Huh? I know. So from here, Do you have all three sides of the triangle known to you? No. So let's find that first. If we use a squared plus b squared equals c squared, which one has to be the c? The hypotenuse, because that one has to be the longest side. So therefore, is that the one that you're looking for or not? Yes. How'd you know it was the one you're looking for? It's across from the right angle. So I have to take 7 squared plus 24 squared equals I don't know squared. Which is a lie, I do know what it is. What is 7 squared? Anybody know what 24 squared is? And 576 plus 49 is? 625. How do you get rid of the square? Now, for this particular model, do you use plus or minus for this? No, because you're not going to have a negative distance. Anybody know what the square root of 625 is? 25. So that means this is 25. Now, once I have that, that's the first step. If you don't have all three sides, find all three first. Now, from here, you're going to write all 6 trig ratios, and then you're done. So the sine ratio, you guys told me was the opposite, which, like Bryce said, was the one across from it, over the hypotenuse, which is the number you just found. Cosine is the adjacent side, which is next to it, over the hypotenuse, which you just found. Tangent. Yeah. Tangent is the opposite side, which we said was 24, over the adjacent side, which we said was 7. Now writing the new ones. Cosecant is 25 over 24. Secant is 25 over 7. Cotangent is 7 over 24. And I'm done. That's what you're going to have to do. Half of your assignment is going to be just like this. You have 3 of which I'm going to give you that are just like this. Where you have to find the missing side and then you have to write the 6 ratios. That's it. Okay? Are you guys comfortable with that, or would you like me to do another one?
No, that's good.
Okay. Then the second type that you're going to see is you're going to see something like this that's going to say the sine is 4/7. I want to know the other 5. Okay? So we have to find cosine, tangent. We have to find cosecant. We have to find secant. And we have to find the cotangent. So we have to find the other 5. I'm giving you one. Do you know one of them right away? Which one? There's 3 C ones. Okay, what is it? 7 over 4. That's easy. Okay? Now, here's how I go about finding the rest of this. This, to me, is better represented as a picture. So all I'm going to do is I'm going to draw a right triangle. Does it matter what kind of right triangle it is? Absolutely not. I always put my theta down in that corner. Now, when it said sine was 4/7, sine was what 2 parts? So the opposite over the hypotenuse. Now, what is the missing part that you need? You don't know the adjacent. How do you find it? A squared plus b squared equals c squared. And which part is a and b? And b is I don't know? And 7 is my hypotenuse? What's 4 squared? What's 7 squared? 16 or 49 minus 16? Does the square root of 33 reduce? If you try to type in the square root of 33 on your calculator, you should get 5 point blah, blah, blah. That goes on forever. Unless you want to write that number for the rest of your life, you leave it as the square root of 33. Now, if the square root of 33 itself reduced, then we would reduce it. But that's 3 times 11. Does anything share in common that we circle and take out? No. So I'm going to leave it as root 33. Now can I finish out the rest of them? Yeah. So what's the cosine? What's the secant? Quick question for you guys. Are you allowed to have square root in the bottom of a fraction?
No.
No. So how do I get rid of it? To the top and the bottom, right? So I end up with 7 root 33 over what?
33.
Good. Can 7 over 33 reduce? No. So that's the secant right here. What about tangent? 4 over root 33. Can you have root 33 on the bottom? No. How do you get rid of it? Times it by itself, top and bottom. Kind of the same process as what we did for secant, right? So what's my final answer? Can any of that reduce? No. What about the cotangent? Good job, you guys. That's it. There's no shoe drop on here. There's no catch like you guys always think I'm going to give you. But on the first one, you may have to find the missing side first and then write the 6 ratios. On the second 3, they're going to give you one of the ratios, work backwards to find the side, and then write the rest of the 5. There's no hidden agenda. There's no anything else. This is it. Are you guys comfortable with this, or do you want me to do another one? No. Okay. So on 466, 6, 8, 10, 14, 16, 18.